Hello, and welcome to a little video on formal reasoning in Euclidean geometry. First, let's begin by reviewing how we properly name angles, and then we'll talk about properly naming segments. Anyways, the first one, and make sure to pause it to fill this in, is use the three letters that represent the vertex and one point on each ray. Make sure that the vertex is the letter written in the middle. The vertex is where those rays meet, right? It's that middle part. So the vertex is this point. These are two rays that meet. That's our vertex. Alright, anyways, the second way is only using the vertex, and the third is using a number or a letter on the interior of the angle. Sometimes in big geometry problems, you'll see an angle inside of a shape or of whatever problem you're looking at labeled with a number or a lowercase letter. On the outsides of angles, you will generally see them with capitals. Anyways, let's practice that. Number one, let's name this angle in all three ways. First, let's use the letters on the outside. We need to make sure to use the two letters of the rays and the vertex stays in the middle. I need to use this angle symbol. That's shorthand for angle. I can start with N and then go to M and L. That's one way of naming my angle. I guess I don't really need to highlight that. I could also go the opposite way. I can start with L, then M, then N. That's fine too, as long as the letter M is in the middle. Method number two is just using the vertex, so just angle M. We're going to do this less often because we're going to be dealing with multiple vertices, multiple angles. We need to be specific on which ones we're looking at, so using the three letters is the best way of doing it. The third way of naming our angle is by using an interior. We do have an interior number here. We have a 6, so I'm going to call this angle 6. Let's look at letter B. All right. The first way is using the two letters on the rays and the vertex in the middle. We have two ways we can do this. We can go from A to B to C, which I find visually appealing, angle A, B, C. Or, of course, we can start on the other side and go C, B, A. That's still correct because the letter B is in the middle and that's the vertex. Speaking of the vertex, method number 2 is just using angle B. And method number 3 is using the interior number or letter, in this case, angle 3. Letter C. The first way is using the 3 letters. We can go R, then Q, and then P, or we can go the opposite direction. So we can go angle R, Q, P, or angle P, Q, R. We could also just use the vertex and call it angle Q. And of course, we could also call it by the interior number or letter, in this case, angle 2. Letter D. First, let's use the 3-letter method. We got angle H, G, F, and angle F, G, H. As long as G is in the middle, we called it correctly. Here we can also call it angle G with just the vertex, and we can call this angle 1 because that's the number on the interior. For these last 3, please take a second, see if you can get these right, pause the video, and circle the different ways to properly name each angle shown. Alright, letter E. The correct ways to name this angle are letter A, angle B works, angle ABC also works, angle 1 works, angle A does not work. A is just a letter at the ray. It's not a vertex. For letter F, letter A works, letter B works. Letter A does not work. I just caught myself there. I did that on purpose to catch you guys, and I got myself. Ugh. Letter A doesn't work. Letter B does. Letter C does. Letter D does. Letter G. A is correct. B is correct. C is not. D is not. All right, let's talk about line segments. So a line segment is a straight line with two endpoints. How do you name a line segment? Use the letters representing the two end points. Then add a line, not a lime, a line over both letters, over the top of both. Make sure to write that down. No, you can just pause the video. Let's practice this. Letter A. First is, or not first, there's only one way to do it. Well, kind of. The only way to do it is to use the two letters, but I never tell you which order, right? It's going to matter when we look at the triangles, but just in naming them, we can practice both. We use X and Y because those are the endpoints, and then we put a line on top. We could have also called it YX. For letter B, we have PQ or QP. For letter C, it's a CD or DC. And for letter D, this is a trick one, it's GI or IG. The whole segment. I gotcha. So letter E, what would that be? Yeah, it's just AB or BA. We don't need those letters in the middle unless we're talking about them. The whole segment is AB or BA. All right, now that we know how to name things, let's dive into that Euclidean geometry and talk about some postulates. First, we got the linear pair postulate, and this is going to stir up some algebra juices. The linear pair postulate states, if two angles form a linear pair, which is a line, let's write that down, a line, then the angles are supplementary. That means add up to 180. Well, in number 1, if ABC forms a linear pair with CBD, use the linear pair postulate to determine the value of x. Okay, well, ABC plus CBD equals 180. Well, angle ABC is 5x. Right? Because we could label an angle by the outside letters or by its interior. Angles CBD is x plus 30. Okay, here we go. What's the first thing we can do on the left-hand side? We can combine some like terms. We can combine 5x and x. 5x plus x gives us 6x. Everything else stays the same. Next, let's get rid of that 30 by subtracting. It was plus 30. I'm undoing that by subtracting. We have 6x remaining on the left. 180 minus 30 is 150. And we got one last step to do. Remember what it is? It's divide by 6. 6 divided by 6 is 1. Perfect. We just want x by itself. 150 divided by 6 is 25. All we wanted to do is find the value of x, and so we did. Number 2. If ABC forms a linear pair with CBD, let's use that linear pair postulate again to find the value of x. So let's practice that again. ABC is 5x. CBD is 4x plus 18 this time. But it still equals 180 because they're supplementary. It's the linear pair postulate. Similarly to number 1, what should our first step be? We should combine the like terms. 5x plus 4x is 9x. I'm going to bring everything else down because we didn't do anything else. How do we undo that plus 18? What should we do to both sides? Yeah, let's subtract 18. Hopefully that's what you thought to yourself. Okay. On the left, it's just 9x equals. On the right, 180 minus 18 is 162. For our very last step, let's divide both sides by 9. On the left, 9 divided by 9 is 1. Perfect. We wanted that. And then 162 divided by 9 is 18. We wanted to find the value of x, and so we did. Okay. Next, I'd like to talk about some definitions and then some more theorems. First, the definition is congruent. This is when two objects are identical in form. This is, in the case of angles, we're going to be using this a lot. They have the same measure. So, what I mean is, I know they have the same measurement, but I have not measured them. That's what congruent is. We use that equals with a squiggly line. And I needed to mention that word because the next theorem I wanted to mention is the vertical angle theorem. This states the opposing angles of two intersecting lines must be congruent. So, opposing angles means angles across from each other. Intersecting lines means lines that cross each other. In this figure, if you take a look, angles 1 and 3 are across from each other. They are vertical angles. They will have the same measure. I know this without having to measure them. All right. I have 4 types of postulates that we are going to be practicing and doing some algebra with. Okay? We're going to be doing lots of this practice in class after these notes. So if you miss these, make sure to also get that classwork and catch up. Number 3 has all of the postulates. 2 of them we already talked about, the vertical angle theorem and the linear pair postulate. So you'll see them pop up. We're going to practice the rest in class together. All right. Number 3. First we have G, F, H, and K, F, H are supplementary. Let's mark that. G, F, H is this angle. This is how we mark angles, with a swoop. Then let's mark KFH. KFH. I'm going to mark it with 2 swoopies because it's a different angle. If I were to mark a third one, I'd have 4 swoopies. I could do tick marks on them. We'll talk about that too. Anyways, these two angles are supplementary. Supplementary means they add up to 180 degrees. So let's write that down as well. Angle GFH plus angle KFH equals 180 degrees. This is the linear pair postulate. Yes, we can absolutely shorthand this later, but right now for the definition, you gotta write it down. Since you're just watching me on the video, why don't you pause it? And I'm gonna scroll on to the next one. Letter B. Oh, I forgot to fix this. These need little hats. There we go. Letter B says RS plus ST equals RT. First, let's see what that means in this image. RS is from R to S. Since it's a straight line, I'm going to mark it with a tick mark. This is what a tick mark is. It's just a little line. And then I got ST. This is ST. I'm going to mark it with 2 tick marks because it's a different little line segment. If I were to label another one, I could use all 3. But here it says that RS plus ST equals RT. This is RT. This is essentially saying if I add 2 small pieces, it becomes a larger piece. This is a little bit uncreatively named the segment addition postulate. So adding pieces of a segment makes a longer segment. Letter C. Oh, that I typed twice. Bloop, 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 bloop. M. Let's define that M, huh? This little m means measure of. Okay, so the measure of angle WXZ plus the measure of ZXY equals the measure of angle WXY. Well, let's mark it up so we can understand what this means. WXZ, I'm going to mark that one with green. WXZ is this angle. I know that it's this angle because I'm following these letters. Okay? Plus angle, the measure of angle ZXY. ZXY. So that's this one. I use 2 arches. And I add them up, I get the measure of WXY. I get this whole guy. Oh, well, this is, again, very uncreatively named, the angle addition postulate. Essentially what it's saying is if I add 2 pieces of angles together, they create a bigger angle. So they do. Letter D. Angle GFJ is congruent to, meaning the same as, exactly the same, I just don't know the measurement, angle HFK. Let's mark it. Angle GFJ, so that's this guy, is congruent to HFK. I'm marking both of these with 1 arch. I'm doing that because they're the same. And I want to make sure whoever's looking at it sees they both have a single arch. That must mean something. And it does. This is actually our vertical angle theorem, I guess. Vertical angle theorem. Vertical angle theorem. This is when we have two lines that intersect. They form angles that are congruent to each other. The opposing angles are congruent to each other. I was missing a word. All right, so these are the four theorems we're going to work with because these allow us to do some algebra and geometry. And we need to, freshen up our juices with that. We just did some geometry that required no algebra, and we need to, keep that alive. So for number 4, we're just going to practice a little bit, and then I'll send you on some classwork. For 4, I want to find the measure of the unknown quantities, name the postulate in order to solve it. Okay, here I see a straight line with one angle named and the other one is x. This is the linear pair postulate. I know that because it forms a line. The other option I would have had is the angle addition postulate, but this forms a perfectly straight line. I know what it should equal. The linear pair postulate states that if we have a linear pair of angles, they're supplementary. So that means x plus 118 equals 180. Only have to do one step to solve it. That's subtract 118 from both sides because we were adding. And we have that x equals 62. Ooh, let's try letter B. Here I have two angles marked with one arch across from each other. This is the vertical angle theorem. We got two line segments. They're intersecting, and we have two opposing angles labeled as congruent. That means I can write 35 equals 9x minus 19. Now here, it would be silly for me to ask you to find the value of the angle on the right side because it's 35. Let's find what x is. The first thing we've got to do here is add 19 to both sides. I'm doing that because I had a minus 19. On the right, all I've got left is 9x. On the left, I've got 54. And then our last step here is to divide both sides by 9. 54 divided by 9 is 5. X equals 5. I feel like something's wrong here. Why does this feel wrong? I need to double check my math. I don't know why, but something feels wrong. I might be just doubting myself, but that's okay. Yeah, of course, it's not 5, it's 6. Holy cannoli! Oh, my goodness. Oh my goodness. You know what? I'm just going to blame the fact that I'm doing this at 6 p.m. I shouldn't be doing math this late. It's crazy. X equals 6. Perfect. All right. Okay, I'll have to do that classwork. But if you have any questions on this, please feel free to ask me. Yeah, otherwise have a wonderful rest of whatever day it is for you. Bye.